Good morning, everybody, and thank you for joining the Sprayed Concrete Ask the Specialists session this morning. This is the third session we have had of webinars run by the Structural Concrete Alliance, so thank you very much for joining this morning. Just waiting for a few more participants to join, giving them a chance, so we will begin our question section in a moment. If I could just run through some housekeeping very quickly with you. This webinar is being recorded. It will be shared on the Sprayed Concrete website and also the Structural Concrete Alliance website. If you would like to ask any questions to the specialists, please feel free to use the chat facility, which is at the bottom of your taskbar. I think we're all fairly well versed in using Zoom now, but if you do have any problems, please just either put it on the chat or email through to us. We will be monitoring the chat. We will also be monitoring the questions and answers section, which again appears at the bottom of your taskbar. These questions will be asked throughout the session. They will be mixed up with the pre-asked questions that we have had submitted by the public. So thank you very much for anybody that has submitted them as well. So just very quickly to remind you about the Competition Act and draw your attention to the slide that is on the screen. If we have any questions that are contentious and we think that breach this Competition Act, we will not ask the questions. So please be mindful of that. It just makes everything a lot easier today. So just going through some feedback about the Structural Concrete Alliance and the Sprayed Concrete. The Alliance brings together the Concrete Repair Association, the Corrosion Prevention Association, and of course the Sprayed Concrete Association. It provides a single coordinated voice and a source of reference for the structural concrete refurbishment and repair industry. We do a series of events, we do technical presentations, we do technical notes, and the big thing at the moment is training as well. The Sprayed Concrete actually have their own specialist training programme, which is an operatives card, which is accepted on all sites. And also we are looking to get a number of assessors qualified so we can put operatives through the NVQ. So moving on to the main part of the event now, the questions and answers session. As I say, please do put any questions on the chat, and I will now introduce you to the specialists, our first being Alex. Good morning, Alex.
Yeah, morning, Lauren. Thanks for that. Morning, everyone. Welcome again to today's Q&A from the SCA. I'm Alex Bidmead. I'm the Southern Area Sales Manager for FOSROC and also the Vice Chair of the SCA Association. I'll be fielding the questions out to the panel today. Like Lauren said, if anything crops up as the guys are answering, you feel like you want a bit more of a different aspect on that question, please just shout out and we'll get on to that as well and ask any subsequent questions as soon as we can. And with that, I'll hand over to Stuart.
Good morning, everybody. My name is Stuart Manning. I'm past chairman of the Sprayed Concrete Association and for my sins now Technical Director of Shotcrete Services Limited, who are a specialist civil engineering company. We do a various range of civil engineering activities, and they include all forms of spray concrete, dry process, wet process and the likes. And with that, I will hand over to another colleague, Bill Jones.
Morning, everybody. Thanks for joining us. I'm Bill Jones. Until recently, contracts manager for the BAM Ritchie's Spray Concrete division of BAM Nuttall. Now recently just retired and member of the Spray Concrete Association as an individual advisor. With that, I'll hand you across to Daniel.
Good morning. I'm Daniel Williams. I've worked in the construction industry for 42 years. Started off life working for a civil engineering contractor and did my training with them and the Highways Authority. And I've been selling construction products for the last 30 years. My 17th year in FOSROC, based mainly in the southwest.
Great, thanks all. Right, let's go straight on to the first question we received. And that being, what are the typical applications of sprayed concrete? Who wants to go for that, Daniel?
Yeah, I can. I'll start with that. Sprayed concrete can be used for a variety of options, really. In the main, anywhere that concrete is used, you could spray concrete. That's sort of fairly true. Structural repairs, repairing structures such as bridges or retaining walls and the like. Spray concrete's a good way of getting product into place fairly quickly, saving downtime and possession time on things like highways and railways, etc. Spray concrete's also used for things like tunnel linings or piled face retaining walls, for example. Where getting concrete into place without the use of formwork is important, because that would add greatly to the time taken if you had to shutter everywhere inside a tunnel, for example. Things like embankment stabilisation, landslips and the like, used in conjunction with soil nails, being able to re-establish embankments is a typical application as well. What you can also do with sprayed concrete is create bespoke forms such as curves for skate parks and swimming pools, canopies and the like. We got some photographs up there on the screen showing some of these typical applications. The one in the top left was a landslip, and that's been put back using soil nails and dry spray concrete. The one in the top right is a weir on a river, and the one at the bottom of the slide is a jetty which is prepared ready to take dry spray concrete. So sort of typical applications which sort of a non-standard sort of construction using formwork and pouring concrete by traditional methods would be very, very difficult in these applications. Anybody got anything to add to that?
Thanks, Daniel. Thanks for that. Well answered there. I'll go on to the next one. What finishes can be achieved with sprayed concrete? Who wants to have a go at that one?
Happy to do that one.
Okay, Bill, go ahead.
Because we as the spray concrete industry are frequently asked, well, what can you do with spray concrete once it's in place? And we can do a lot of things with it. If we just place spray concrete by any of the methods, wet or dry, and Nosman puts it into place on that slope that we just saw there, or on the marine jetty, and walks away, that is what we call as sprayed finish. As it says on the tin, put it in place, leave it as it is, and walk away. And that is like a rough pebble dash finish. The roughness depends on the aggregate size that we use in the mix. So we can just leave an as sprayed finish. Neither of those two photographs are as sprayed finish. What we can then do with the as sprayed material while it's still green is what we call cut and flash. Now, we use a serrated edge trowels. We cut the surface of the green concrete because it's self-supporting, and then we apply a very thin layer of the same material in as we call a flash coat. And that leaves a nice flat surface. The bottom right-hand picture shows this one with a textured finish. And again, the texture depends on the aggregate size. The smaller the aggregates, the smoother, if you like, texture. The larger aggregates, a rougher texture. If we want something better than that, then we can do what we call a cut, flash, and float finish. We cut the material while it's still green to the right level and line, apply the flash coat, as we've just done with a cut and flash, but then using either wooden or steel trowels or even sponges, we can carefully finish that surface to make it even smoother. And that's what the bottom left-hand photograph shows. I think I want steel float finish, which provides a very, very flat finish. Finishing can be problematical if you try to overfinish the material while it is still green, because as with all concrete, it can bring moisture to the surface, which then evaporates and can cause some shrinkage cracking. So we have to be careful what we do. Majority of work that's done is either left as sprayed in tunnels or marine environments, or cut and flash. We tend to advise people not to go for the steel float or wood float unless they really need to, because of these risks that we have in overfinishing the material. On the Spray Concrete Association website, we did a demonstration at Leighton Buzzard a couple of years ago, where we demonstrated and videoed the various methods of finishing sprayed concrete. And so if people are interested in the various finishes that we can do, there should be that video available if you contact the Spray Concrete Association. Those are the basic ways of finishing sprayed concrete. Speak to the contractors, especially if you want to go for the steel float or the wood float finish. That's it for me.
Great, thanks, Bill. Thanks for that. Anyone want to add to that? Well, I'll move straight on. Okay, so the next one we've got is what colours can be achieved with spray concrete. Stuart, I don't think we've had one from you yet. Do you want to take this one?
Yeah, thanks, Alex. Yeah, I'll have a go at this one. Colours, yeah, various amount of colours we can use in spray concrete. Obviously, the standard colour is concrete grey. The colour of that concrete grey can be altered slightly if we use a microsilica, which is a dark powder, or PFA in our mix. That would give a darker grey colour to our finished material. If we wanted a lighter grey, we would go with a slag, a GGBS material, which is a whiter powder in our mix. And that would generally give us a lighter texture. So sometimes if we're having to match into adjacent structures and the likes of that, architects may well want us to try and look at a different grey to achieve that. If we're going towards colours, and on the screen you can see a red and a yellow as an example there, we would start with a base mix being a white material. Colours are all expensive, so we would generally do our bulk structural layers with the cheaper material, which is just a standard grey material. We would bring that out to within about 30 millimetres, 25 millimetres of the required finished profile. And then we would put on our colour coat, because, as I say, the colours, whether it's white concrete, whether it's a red pigment or a yellow pigment within that material, it adds cost. So we try and keep it to a minimum thickness. If we're producing the different colours, so we want a yellow or a red, we would generally use the dry process. So we would use a white base mix, as I've said, a white cement base mix, and we would then add the pigments. Sometimes that comes in pre-blended once we've done some trials and we know how much colour we want to put in that. Other times we might site batch, so we may use the white material and then add a pigment in a pan mixer or the likes to create the colour we want. We could do greens as well, and we have done blues. Blues use cobalt, and cobalt is a very expensive raw material. So, you know, depending on the colour that an architect or a client wants, you know, you can get quite considerable cost variation on that. And the colours can be finished, as Bill said. We can leave it as sprayed. Those examples there are of as sprayed dry process material. So you can see the fine aggregate in that. But if we wanted to go with a float finish on that, we could then screed or float the surface to create a uniform texture. So I think that's probably all I can say on colours. If you've got any other questions, stick them on the chat. Thank you.
Well, I think Lauren might have something that's come in there.
Thanks, Alex. We've just had a very quick one on the questions and answers relating to that, Stuart, or anyone else who wants to answer it. I have seen many colours or through coloured concrete not performing very well. Is this different from Stowe coloured? Are you able to give any feedback on that, Stuart? Or Bill, Daniel?
Yeah, with a Stowe type render, it's all manufactured in a factory, so it's key to getting a uniformity. Depends what, as I said, what you want out of the finished product. If you want a uniformity, then we can get the material pre-blended, pre-batched, so we should get a fairly uniform outcome. With all types of concrete, it is water cement ratio dependent. Whether that's a grey, if we have more water, it will tend to be a lighter colour. With colours, if the water cement ratio changes slightly, it can affect the colour. But you know, we would recommend doing trials to ensure that the client is happy with the outcome. When we're using a dry process, it's the nozzleman that is tweaking the water cement ratio, the consistency of the material as he's spraying it. It doesn't change by very much because he's fairly limited in how he sprays it, but it can have an effect. And also if you trowel it, you know, if the guys are trying to get a finish on it or a sponge on it, and again, put a bit of water on a sponge, that can affect the colour end product. So just, yeah, be careful and you know, always advise doing trials to make sure that the product is what the client expects.
It's probably true to say as well, Stuart, that all pigmented concrete does sort of lose that colour sharpness over time anyway. If you think of things like block paving and whatever, you know, over a period of time, they do fade, and that is a characteristic of pigments, really.
Yeah, definitely, Denzel. You've got a bit of weathering going on there, and that will always dull the surface down, and you'll probably get a bit of algae growth and stuff, which can discolour as well.
I think one thing that can be said with regards colours and finish of spray concrete is that without any pigments, and you've got a standard grey sprayed concrete, there will be what's described as cloudiness within that grey. So it'll be slightly different shades of grey because of the different water content, because of different rates of evaporation from that surface. And so sprayed concrete is not uniform, whether it's standard grey or coloured, pigmented. It is cloudiness that is within the sprayed concrete. So you won't be very, very difficult to get an absolutely uniform coloured finish.
Where are you going with that, Bill? How many shades of grey are there, do you think?
Let's not go there. Come on.
Yeah, great. Thanks, guys. Yeah, I think it's like Stuart said, a trial is also a key thing, just to represent what you're achieving for the client, and then everyone can agree on that. Right. We'll go for the next one now. It's a question 4 that we've had in. What is the minimum and maximum thickness of spray concrete that can be achieved or applied? Who wants to take this one on?
I'll step in on this one then, Alex.
Okay.
As with, well, particularly in the case of sprayed concrete used for repairs, the minimum thickness would be, as per the guidelines for any repairs, really at 10 mil. Feather edging isn't good for anything really, so a minimum of 10 mil, with a maximum then depending on how the material can stay in place. But generally, you'd expect to be able to build up to about 150 millimeters in a vertical application, with about 90 millimeters in overhead situations for soffits, etc. You can build up in layers, and if you consider using rapid setting materials, you can also then sort of increase the thickness from that point of view. That relates mainly to sort of dry sprays. Wet sprays are a little bit more sort of a concern, because you can end up with a little bit of slumping if you put it on too thick. Stuart's probably got a little bit more experience of wet spray. So Stuart, can you come in and comment on that one?
Yes, certainly. I think there's just been a question up on the forum there. Thank you, relating to that. Wet spray, we're spraying a material, if it doesn't have any admixture in it, at around about 80 slump. So we are dependent on the material supporting itself. Now that will be the thickness will really depend on how much reinforcement we've got in the structure. It's key when we're spraying vertical walls that the reinforcement is fixed tight. We'd expect L bars back to the piles or back to the substrate, because we're loading that steel in the very short term when we're spraying it. But we often are spraying walls that are 300 thick, 400 thick in one pass out to the front face of reinforcement without any admixture. That could easily go as far as 500 mil in a pile cusp. And we could take that up in one pass to around about 2 meters high. It is mix dependent, it's slump critical. So our mix designs are very, very important to allow us to build up that concrete. So we would build out to the steel, and the steel would support that material in its fresh state. We run a high cement content, so that material would start going into its initial step fairly quickly, and within an hour the material will be fairly firm. So if we've got another load of concrete ready mix coming into a site, maybe it takes us an hour to spray that load. By the time we finish spraying, the nozzleman could go back to carry on taking the wall up to the next level. So generally he'd start on his feet, spray up to around about 1.5 meters to 2 meters, and then he might get into an access machine and then carry on spraying the wall up for the next section, probably do another 2 meter band. So if we're building a 9 meter high wall, I would expect to see that wall built up probably in 3 passes, if you like, out to the steel. And once that wall has been built up to the 9 meters, we would then put on a top coat, if you like, which would provide the cover to the reinforcement. And that coat would be between 25 and 35 mil thick. And it's that layer that would then be finished in some way, as Bill has said before, whether it's cut and flash, less as sprayed. We would then put the finish once the total wall, structural wall is being built to full height. So I hope that answers the question. Overhead wise, sorry, if we're using admixtures in tunnel linings, we're spraying up to 300 thick. Is common, and that's sprayed in a continual process. The nozzleman will build it up in sort of around about 75 mil thickness layers, but by the time he's sprayed from one side of the crown of the tunnel to the other, it's gained enough stiffness, because it's going off quickly with the admixed, to carry on spraying. So he wouldn't actually stop the spraying process to complete the whole 300 thick crown section, which might take him half an hour to spray, and he may put in there 12, 14, 18 cubic meters. So it would be a continual process. It's green on green, so we would class it as a one pass lining, although it's made up of a number of short passes. So I hope that answers those questions.
I think we covered those well. Thanks, guys. Right, if we go on to the next question we have, and I think Bill touched on some reasons why earlier, but why might spray concrete crack? Anyone taking that one on?
Yeah, I don't mind doing that one. Cracks in concrete. Concrete cracks, whether it's cast, whether it's sprayed. Doesn't matter how we install it. If we don't install it correctly, concrete can crack. So if we look at the various types of cracking that may occur in sprayed concrete, we can get structural cracks. Structural cracks will be formed, or will form maybe because of poor design, maybe because of unequal loading to the wall, something which a designer didn't know was going to happen. It could be an older structure that we're refurbishing, and there's existing movement. So design is obviously critical. We need to make sure the right amount of reinforcement has been designed into that structure. We can also get thermal cracking, shrinkage, expansion. So the structure must be designed with that in mind. So we'd expect expansion, contraction joints, as you would get in a standard concrete, cast concrete, should be looked at in a spray concrete, especially if we're going with thinner thicknesses. Sometimes sprayed projects use a thinner thickness of concrete than you would say cast, and therefore expansion contraction can be a bigger factor. So movement joints are critical. We can get drying shrinkage. Bill mentioned it before, especially when we come to finishes. We don't use a front face shutter, so we spray that material on, and it's left exposed to the elements. If it's a sunny day, if we're in a windy environment, you're going to get a lot of moisture loss through the surface of the material. So curing is absolutely critical to reduce that dry and shrinkage, micro cracking that you could get. It's very important as soon as we can get a sprayed membrane, a curing membrane on there. If that's not possible, may use a water curtain or Hessian draped over the surface, or polythene. Anything that you would do to normal concrete to improve curing, all the better. You know, if you're spraying a floor slab or something like that, to get some water on it fairly early on is another great way of curing it. So really curing is as you would in any traditional structural concrete, but because we haven't got shutters to hold that moisture in, it is a little bit more critical. Bill also mentioned finishing the concrete, and if we're troweling the surface, we can induce plastic cracking. So when the guys are troweling it, they're putting energy into that surface, and that can lead to micro cracking. You often see it on renders. A render wall can look stunning, but you spray a hose pipe on it, and all of a sudden you'll see this crazing effect as it starts drying out. And that's because the micro cracks that have been formed when it was troweled have absorbed a tiny bit of moisture, and you can then often see the cracking or crazing. They're say very small cracks, and that's often caused by over troweling. A benefit that we can do in spray concrete is, as I said before, to apply the 35mm finishing layer as a separate layer. So the concrete underneath is gained a bit of stiffness or gained a bit of strength. We may even put it on the following day. We'll get an excellent bond onto that screeded or as sprayed surface with our finishing layer, 35mm layer, and that will reduce the amount of plastic cracking we get when we finish it. So it is key to make sure the guys don't overwork the finish to prevent any plastic cracking. So they're the main forms of cracks we can get in spray concrete, and not dissimilar to standard structural concrete.
That's great. Well done, Stuart. Answered that fully. On to the next one. What are the differences between wet and dry spray concrete? Who fancies that one?
I'm happy to take that. The clue's in the question. Wet and dry. Wet spray concrete is basically ready mix, a specialist ready mixed type concrete, slightly smaller aggregate size than your normal shutter and pour concrete, but it is a ready mix supply which is then placed into a specialist concrete pump. That concrete pump takes that wet material, pumps it along hoses to basically the discharge nozzle at the end of the hose. At that point, the wet spray concrete, we inject high pressure air, and that high pressure air projects the wet concrete onto the target area. And so that's how we place wet spray concrete using a modified ready mix material. Dry sprayed concrete takes dry materials, pre-bagged, pre-blended in the factory, places those dry materials into a specialist machine that meters the dry material into an airstream. And that airstream transmits the materials along the hoses to the discharge nozzle. So we've got dry material going through the hoses rather than the wet materials. In the dry spray process, at that discharge nozzle, we inject water. And this is where the nozzle man, as we call him, operating the nozzle, controls the water content that's going into the dry spray material. So we've got a dry flow of material conveyed by compressed air, water injected at the discharge nozzle, and that is then projected onto the work area. And so we've got two different types of process, using a ready mix type material or using a bagged dry material. One of the big differences in the wet spray process, the characteristics and the properties are determined at the ready mix stage. And so the proportion of cement, the slump, the additives that determine the finished characteristics and properties of the material are determined at that stage. With the dry spray, we've got all the blended materials, but the nozzle man adding that small amount of water is critical. Stuart mentioned there's a range of water that the nozzle man can add in the dry spray. Too dry and the whole material just doesn't have enough moisture in it, enough water in it, and the process is very dusty, and the placed concrete doesn't have enough moisture in it to hydrate properly. Too wet, and basically we've got soup running down the wall, and so that it's critical that the nozzle man is experienced enough to judge the amount of water being added to the dry spray material. Another big difference between wet and dry is the rate of production. Stuart mentioned we take a ready mix truck and we discharge that within an hour. So you've got 6 cube an hour at least going through a wet spray process. In tunneling process operations where they're using wet spray, it can be up to 30 cube an hour. And that is critical in the tunneling process. The whole of Crossrail was pretty much done with wet spray concrete. If you look at any photographs, you'll see the finish of that wet spray is as sprayed. In the dry spray, we've got some photographs here. And so the wet spray, we've got our ready mix truck in the left-hand picture, discharging into the spray concrete pump, which pumps it through to the nozzle man who's in that cherry picker. And so he's applying that basic ready mix directly to the wall. The right-hand picture is also a wet spray process from memory, and that is on CTRL, and that's the nozzle man applying wet spray concrete to piles. Those processes are going at sort of 6-12 cube an hour. The dry spray process, because we're taking pre-bagged materials, feeding them into a machine, could be possibly 2 to 3 cubes an hour. And so there's a huge difference in the productivity rate. Wet spray, unfortunately, doesn't have a good stop-start capability. Once we've got the ready mix truck there with the 6 cube of concrete in it, we want to get it into that pump and onto the wall. With dry spray process, we can stop and start. The materials are dry until they get to the discharge nozzle. So we can stop that process at any stage, and basically we don't need to clean the equipment down, just need to make sure that that dry material doesn't get wet. And so they're the real differences in the wet and dry process. We're taking wet materials or we're taking dry materials. Anything else?
Yeah, thanks, Bill. I think we've got another question live, which Lauren can hand over.
We have, thanks, Alex. One from Des on the questions and answers, just linking to that, Bill, and I think you pretty much covered it, but what is the recommended water to cement ratio for wet sprayed concrete?
Wet sprayed concrete. Stuart?
Yeah, recommended. It really depends on design. So as in the spraying process, as we said, we generally spray at a stiff workability. So we're anything between 50mm slump to 80-90mm slump for a standard material. If we're in tunneling, we might move that to an S3 with admixtures, but we've always got a high cement content. So our water cement ratios are generally pretty low. anything from 0.35 to 0.4. We've recently worked on a project where it was a design criteria that we had to be a 0.35. So from a design perspective, you would set your parameters, your design parameters, in the specification, and the spray concrete contractor would look to design a mix to meet that. We have a problem in our industry that we can't go to low strength. We find it very difficult to spray a C15 or a C20 or a C25 material, or go to a high water cement ratio, because it doesn't suit the process. So generally, our water cement ratios would be 0.35 to 0.4, possibly reaching 0.45 on the rare occasion. The dry process, as Bill said, we're adding water at the nozzle, so that the nozzleman can spray a very dry material, but he has to be careful he doesn't go too dry, and we don't have that water for hydration. So you know, you're right on the 0.35 end of the spectrum, if not a bit less, with the dry process.
I've seen a supplementary question just come in regarding the dry process with powder admixtures. Yes, the dry process materials produced by the major manufacturers do contain admixtures. All the manufacturers are quite secretive about their mixed design, so they won't tell you exactly what's in it. But we know that there's going to be cement in there. There's going to be possibly some cement replacement. There could well be some plasticizers in there, really to try and improve the sprayability of that material and minimize any wastage, any rebound, as we call it, from the material. So there are certainly admixtures in the dry powder process. What those admixtures are, try and twist Alex and or arm, or Daniel's arm. They might tell you in very general terms, but they won't give you a mixed design.
No, that's certainly the case. That is the clever part, really. But yeah, there will be plasticizers and there will be accelerators as well, especially in the rapid set products.
Just one more on. Sorry, Alex, just to interrupt you. They're coming in thick and fast on this question. So just one more into relation to this question. What are the specialist thoughts of dry shotcrete rebound and its relation to end material characteristics and performance? Who wants to take that one? Don't all rush.
Well, can you repeat the question?
Of course, yeah. What are the specialist thoughts of dry shotcrete rebound and its relation to end material characteristics and performance?
Right.
Okay.
We get rebound, and that's the portion of the material that bounces back from the work area due to the kinetic energy normally in the aggregate, and the rebound should never be reincorporated in the finished process. The rebound on a vertical surface, that rebound will end up on the floor, and that should just be moved out of the way and taken as waste. If you try to incorporate rebound back into the finished product, you'll end up with a lower quality product. And so rebound is the accepted wastage that is within the process. And so it should not be reincorporated within the finished product.
I think the question asks about what relationship that bears to the quality that you get. The amount of rebound won't necessarily affect the quality of the end product. As Bill said, you wouldn't reincorporate that. However, the amount of rebound you get is dependent on the quality of the product that you buy in the first place. A very dusty product will have more rebound, and it depends on the quality of the aggregates and everything that goes into making that product. I think there is a question that we've had beforehand, and we will be covering it a bit later on, but some dry spray products have a much lower rebound than others, and we will cover that a little bit later on.
Yeah, thanks, Daniel. I think we do have a question on Rebound later, so perhaps we'll cover that again, and hopefully we've covered the question that came in. I think on the admixture one, I'd also say it probably relates to what properties you're looking for with the admixture question. So maybe if you follow up with a question, we can come back to you afterwards with some answers on what you're looking to achieve with certain admixtures and the properties of the spray. If we move on to our next question we had in before. So how much shuttering does spray concrete need? I think a couple of guys have mentioned there's no front shutter. So what is it that we're looking to provide? Who wants to take that one?
Well, I'm bored of my voice. I'll have another go. Yeah, shuttering. We do use shuttering in spray concrete. If we're using, say, for example, we had to build a freestanding wall, we would put a back shutter up and spray against that. You would then, if you strip that back shutter, I think most people are very surprised because you'd actually see the grain of the wood on that back shutter, and anyone would think that was a cast wall, whereas the front face would be screeded, as Bill said, or as sprayed or whatever. On this example, you can see on the picture there, it's a concrete repair. It's been broken out, the edges have been cut, so we've got a nice square edge. We've treated the rebar, and we've put a soffit shutter. We've put a bottom shutter in there to make sure that the front edge of that repair is nice and straight. If we wanted to form a drip, if that was a beam, a horizontal beam which had a drip on it, we could put a little bit of angled fillet on that bottom shutter to make sure when we stripped it, that fillet is replicated to match the existing structure. So there we've got a simple piece of shuttering. If we're doing column repairs, similarly, we may use what we call a ladder shutter. It is what it says on the tin. It looks like a ladder, but the edges of that ladder are set to the exact positions of the edges of the column, and again can incorporate any sort of rebates or anything else to match existing structures. And we would spray the central section between the ladder. That would give us an edge to then, when we strip the shutter, to then spray the other side of the column. And we would then use the cast sprayed repair that we've done on one side of the column to act as the edge of the second part of the column. So we would do the two opposing faces of a column with the ladder shutter. We'd strip that off, and then we would spray the other two edges of a column to give us a perfectly symmetrical column. So yeah, that's where we would use the timber shutters. Freeform structures. So for example, things like Selfridges, Birmingham, which most people know, the huge, great big building with the discs all over it, very weird shape. That used an expanded metal system. So where we have very complex geometrical shapes, curvatures of any shape, we actually created some spheres for Dermot Gavin, the Mad Irish Gardener, years ago for the Chelsea Flower Show, and we made those spheres with just rebar and expanded metal. So it's a very fine expanded metal. We spray onto that catches the shotcrete or the spray as we're spraying it. And then we can spray the other side of that expanded metal to ensure that the reinforcement is fully encapsulated, and we've built up to the correct thickness, whether that's 50 mil or 300 mil. So we often use expanded metal as a lost shutter system. That's quite common. That's about all there is on shutters.
Great, thanks, Stuart. Okay, we'll go on. I think this relates back to something Daniel was touching on. Yeah, so how much waste is there with spray concrete, and how is waste measured? So Daniel, do you want to carry on where you left off?
Yeah, okay. I'm a little bit conscious of the time, Alex. We're at 11:15, and I think we got quite a lot of questions, so I'll try and be quick on this one. Yeah. How much waste is there with sprayed concrete? Well, with dry spray concrete, you can expect anything from about 3 or 4%, which is a very, very good figure, up to about 15%. I would say the average would be around about 7 or 8%. And that is stuff what we call overspray that lands on the floor. It's on the applicator's boots and whatever. It's the stuff that Bill mentioned earlier on that will get swept up and thrown away. And so it's Rebound. You wouldn't incorporate that into the work. So you would need to allow a minimum, I would say, of 5% wastage with dry spray. On wet spray, it is again a little different. Your wastage can be absolutely minimal. You will sort of waste product in hoses and the like. You need to make allowance for that, because there will be product in the lines that at the end of your spray session will get thrown away. But you wouldn't expect the same amount of dust to land on the floor as you would with the dry spray. Stuart, anything to add on the wet spray?
Yeah, I will. I just you'll probably hear us mention this a lot from all of the specialists talking, but it is critical that the nozzleman is trained. He is the key person in any spray concrete. Yes, he has support guys around him, but that person is the most critical member of the team. If we're spraying a wall and it's going to be screeded flat, and I overspray it by 100, 200 millimeters, then all of that material is going to be scraped off. So my wastage could be 50%. So if the nozzleman sprays it just about perfect, the lads go, we screed it, we take off the minimum amount, we may have a few low spots, he comes back and just flashes in those low spots, again, re-screeds it, minimal amount. So you could spray a 200, 300 thick wall and be at 5% rebound. Or if it's as sprayed, certainly you could be as low as that. And as Daniel said, it's the same on the dry process. If the nozzleman is spraying it on and he sprays it too thick and the guys have got to scrape it off, it's going to be classed as rebound and waste. It's not rebound, but you've created a waste. So it's critical to the guys doing the work. Nozzle angle as well will increase and decrease rebound. So yeah, all of those factors, a mixed design. Daniel, they produce material with low rebound additives in it to keep it sticky, to make it stay in place. So very critical.
What I would say is, in terms of how the waste is measured, we talk in terms of percentages: 5%, 10%, 20%. And that is the percentage of the total amount of material that we've used on the site, expressed as wastage. So if you've got 100 cube being delivered to the site, 90% is on the wall, 10% in the skips, that's 10% wastage. Some people in the past have said, well, I've got 10 cube on the wall and I've got 10 cube on the floor, so I've got 100% wastage. We don't accept that. We use the percentage of the total material that's been used on the site that's come off as waste. So that's when we talk in terms of 5 and 10% of the total materials used.
Great, thanks, Bill. Okay, so next we come on to the next one we've got, looking technology in construction, and where would you use robotics? Perhaps relates to more of the wet spray side. So Stuart, do you want to take that one?
Yeah, thanks, Alex. Robotics is becoming more and more widely used in all industries, whether it's car manufacturing, the likes of that. Yeah, we're using a lot of robotics in spray concrete now. They're successfully used in tunnelling. It keeps the nozzleman safe. He's not in unsupported ground. So that's a massive benefit. When you're spraying above your head, you don't want material falling down on top of the nozzleman. And it's not a particularly pleasant environment. So use of robotics in tunnelling is widely used now. You can also get increased outputs. The guy's not getting fatigued. He's not holding a heavy pipe full of concrete and holding against the pressure of the material coming out. So you could get a lot of higher outputs per day using robotics. Still not ideal when we've got heavily reinforced structures. The nozzleman is very involved in making sure he gets the compaction around the steel and stuff. So where we've got highly reinforced structures, you tend not to use robots, because the nozzleman's going to give you a better end product. If we're spraying a sawnail slope, one layer of mesh, or even a poled wall with a limited steel, or we're using steel fibres, great use for robotics when we're using a mix with steel or plastic fibres in it. So yeah, it's becoming more and more popular to use robots. We've got simple units that can be mounted on an excavator. when we've got more complex units that have all of the pumps and compressors and everything on board. So they're real sort of standalone units. So yeah, it's an area of the industry which is growing considerably.
Yeah, thanks, Stuart. I think, like you said, it's everywhere. Sort of robotics is being used more and more, isn't it? Right, we've got a question in from the audience at the moment. So, does spray concrete tend to get specified only in unusual, more complicated specialist need applications, or is there growth in it becoming more mainstream instead of traditional poured concrete? Does anyone want to take that one? Well, I think I'll have a quick stab at it while the others have a think. I would say that the nature of construction, some more complicated designs in infrastructure and buildings means that some instances spray concrete is an easier method of application rather than traditional pour and cast concrete. So allowing the access in for the guys to get down is in some cases easier. For tunnel linings and things, it's obviously you can't cast the tunnel lining as easily as you can spray up into that area. So I think it's not taking over from concrete with regards to slab and cast, traditional column and cast slabs, but in the more different areas, I think, like you alluded to, Alan, in your question, it probably is. Anyone else got something there?
I'll chip in. I mean, we do a lot of work for basements. Single-sided shutters is a really big market for wet spray concrete. We can match and improve outputs for single-sided cast concrete walls. We can utilise waterproof admixtures in there to meet basement criteria. So we do a lot of work, you know, around the country. All the spray concrete contractors are spraying a lot of piled walls as a cost-effective solution. Yeah, free-form tunnels, they will lend themselves to spray concrete, and concrete repairs really is a whole element in itself where it's a great use of spray concrete rather than hand repairs. You get better compaction, and it's quite often a better result.
Yeah, I'd agree with that. Yeah, thanks, Stuart. Okay, back onto the pre-asked questions. Should cover off some health and safety as it's so important. What are the health and safety hazards associated with spray concrete, and how do you minimise this? Who wants to take that one?
I'll happily take that, Alex.
Thanks, Bill.
With my health and safety hat on. All the members of the Spray Concrete Association appreciate the dangers of construction sites in general, and the particular dangers of sprayed concrete, risks and the hazards that we have to appreciate. Be it wet or dry spray concrete process, there are operational hazards. In the wet process, we've got a pipeline or a hose full of high pressure concrete, and when things are running smoothly and there's not a problem, there are no problems, there are no hazards, there are no risks. If the process suddenly stops, we can get a blockage in that pipe, and it needs an experienced operative, a competent operative, to know how to deal with those that sort of situation. Similarly, in the dry spray, things can go wrong. The machine can malfunction. There can be a blockage in the air hose that's taking the material to the nozzle, and again, it needs the experienced, competent operatives to be able to deal with that. So there are hazards, there are risks, and this is where the Spray Concrete Association insist that the contractors ensure that their operatives are competent. We've got Lauren mentioned the nozzle man, spray concrete nozzle man card, but that also covers other operations. It's not just nozzle man, it's the machine operators, it's the nozzle man assistants. And so there are operational risks. And like every contractor in the construction industry, we do our risk assessments, we do our hazard identification, and we do our mitigation. But there are these specialist risks because this is a specialist operation, and not everybody appreciates what the risks are in spray concrete. And this is where the experienced contractor comes to the fore, the specialist comes to the fore. apart from the operational risks, we've got the ordinary construction risks from handling cementitious materials. I've seen cases of extreme dermatitis where people have been forced to give up working in the construction industry because of reaction to cement, and cement burns and things like that. And so there are the normal risks that we get in construction, and there are the specialist risks, and they can only be addressed by identifying the risks, doing the mitigation, and ensuring that the people who are undertaking the roles are experienced, trained, and competent. And so in spray concrete, for example, we ensure that we have exclusion zones where we're spraying so that people don't wander through to see what's going on. It's an unusual process. A lot of people haven't seen it before on construction sites, and people get nosy, but we exclude them from the work area. Let the experienced operatives be in there and let them deal with the risks that are there. In dry spray, things can be a bit dusty. We mentioned water-cement ratios, and there can be an amount of dust created in the dry spray. And similarly in the wet spray process, there can be a sort of a mist or a fog, because we're dealing with wet materials which are then aerated. And so there can be a mist or a fog. But all these things are dealt with by the contractors through the normal mitigation methods.
Great, thank you, Bill. Anyone else got anything to add on there, or I think that was pretty thoroughly answered. We are coming up to the hour now, so we will complete our Ask the Specialist session there. Thank you so much to all our panelists. Some really informative answers there for the questions, and thank you to Alex for reading those questions. Meant I didn't have to, so it was a big relief.
Lauren,
yes, sorry,
if I can jump in just a sec. I can see that there are quite a few questions that we haven't covered that have come in this morning as well.
Yes.
And I think what we can do is sort of answer those directly back to the people that have asked them, if that's okay.
Yeah, what we'll do is, as we've done for the other webinars, we will do a post recording. So we'll get the specialists on again and then send the recording out to everybody. Daniel.
Oh, hi everyone, and welcome to this follow-up question and answer session following the Spray Concrete Society Q&A. There were a few questions that we didn't get around to answering, so we thought we'll cover them off today. Just quickly again, I'm Alex Bidmead and the Southern Sales Manager for Fosroc, and I'll introduce you to the rest of the panel, the first being Stuart.
Hi, I'm Stuart Manning. I'm Technical Director for Shotcrete Services, specialist spray concrete contractor that complete all various types of spray concrete. And moving on.
And next we'll go to Daniel.
Hi, I'm Daniel Williams. I also work for Fosroc along with Alex. I'm the Area Sales Manager for the Southwest region.
All right, thanks guys. Right, here are the additional answers that came through on the day. First one being, I've seen many colours of through-coloured concrete not performing as well. Is this different from Stowe-coloured renders? Who wants to take that one today?
I'll start with that one then, Alex. Any coloured concrete does suffer over time with fading. Concrete being what it is with the grey cement, even if you change to white cement, pigments don't give a very bright colour. The main difference between, for example, concrete block paving and clay paving is that clay paving retains its colour because it's a through colour, whereas any pigmented concrete will tend to fade. Store renders are sort of different. You're not just talking about sort of cement-based products there. They are sort of polymer renders and whatever. So that will be a different scenario. Stuart, have you got anything to add to that?
No, I concur with that, Daniel. It's yeah, I think the Stowe has more epoxies in it, so may hold colour for longer. But the yellows and reds and other colours that we've sprayed, they will fade a little bit with time, and that's inevitable.
Yeah, and I think another point is location of the application as well will vary how long the colours are. If it's next to a busy road, say, you'd have a lot of carbon build-up over time, which will fade the colour over time, and you need to bleed at certain points. So that's great. I think we'll move on to the next one we've got then. What are the specialists' thoughts of dry shotcrete Rebound and its relation to end material characteristics and performance? Who wants to take that, Stuart?
I'll let Daniel go with that one. You're a material producer.
Yeah. It doesn't really have much of an effect on the end performance and characteristics of a product. You will get variation between different materials. You can expect Rebound anywhere from low single figures up to possibly sort of 15–20%. However, all the products are formulated. The amount of Rebound you get will vary, but it shouldn't really have an effect on the end compressive strength or compaction. That is purely down to what happens during the application process, but the end characteristics will, the results should conform to the design of the product, and they should do what they are meant to do.
Certainly, we've worked with a number of admixture companies and completed trials for them. It's something we've looked into, and most manufacturers will make an allowance in their mix design for a percentage of Rebound, because we know it's inevitable. So yeah, as Daniel says, if that product is designed for a certain application, overhead application or concrete repair application, you're going to get 10%. Well, that 10% of generally the larger aggregate material is allowed for in the mix design to ensure that it does meet that specification.
Yeah, if the product's designed to be 50 megapascals, for example, and you've got 10% Rebound, it doesn't necessarily mean that if you've got 20% Rebound, that you're not going to get that 50 megapascals. So that the performance will be the same at the end of the day.
Yeah, okay, that's great. Thanks, guys. Moving on to the next one. Does spray concrete tend to get specified only in unusual or more complicated specialist need applications, or is there growth in it becoming more mainstream instead of traditional poured and cast concrete?
I'll grab that one, Alex. We do a lot of basement and structural sprayed applications. Yes, of course, it's always going to be used on the weird and wonderful shapes because it lends itself to that. But as a company, we do a lot of structural walls. Is it becoming more mainstream? There's various factors in that which will affect. If labour costs go up, if timber shuttering costs go up, then it becomes a more of an attractive option to general civil engineering contractors to utilise spray concrete for structural walls. Our base concrete material is slightly higher than a poured concrete because we have a higher level of SEM1. We have a higher fines content, so our mixes are a little bit more costly than a standard poured concrete. If you imagine whether it's a pumped concrete is more expensive than a skipped concrete, so those costs will come into it. But we can save also time program. We don't need hook time, so we don't need cranes to move shutters around and materials. We can spray from the open face, and that is quite often attractive to a lot of civils contractors. So there's a number of positives for spraying walls, and they are becoming slightly more popular, but it really depends on the state of the economy and what the main contractor wants.
Yeah, that's great. Thanks, Stuart. Anything to add, Daniel?
No, I think Stuart's covered that one.
Great. Let's move on to the next one then. I think this is a good one. How does spray concrete hold up when sprayed in marine environments? Comparing that to sort of a concrete wall, and obviously looking at chloride ingress in those environments.
Well, sprayed concrete will give the same performance as any other concrete, really. It doesn't matter whether you spray the concrete or whether you shutter and pour, or in marine environments, occasionally you'll put in an anti-washout agent to be able to pour it underwater, pump it in into below water applications, but the performance of the concrete will be exactly the same at the end of the day. The protection against chloride will be sort of reliant on good compaction, on it being a dense product, but it really doesn't matter how you place the material. The characteristics are going to be very, very similar.
I second that, Daniel. I think it's same with anything. If a concrete is poorly vibrated and the protocols aren't followed when you cast a concrete, then chloride ingress will be higher. Similarly with spray concrete, you will design a mix to minimize chloride ingress. So you'll look at your exposure characteristics and factors and design that with cement contents and the likes accordingly. As I said previously, we do use a high cementitious content generally in shotcrete mixes, sprayed mixes, and that's of benefit to chloride ingress, so or preventing it. So yeah, good mix design, good workmanship. You shouldn't have any difference between a cast or a sprayed material. We've never managed to spray concrete underwater yet, so maybe that's one for the future.
Yeah, that's great. I think that sort of also goes back to the previous question. That actually a lot of marine applications are sort of a bit difficult access-wise, so it does occasionally lend itself more to the spray than a traditional cast concrete application.
Certainly when we're using accelerators and stuff, work between tides very effectively, and your mix is designed for that reason, and it coming under being submerged will only really assist in the curing of the material.
Yeah, that's great. Thanks, guys. Right, I think we'll move on to I think this is our final one, following up from the Q&A. What is the relationship between the aggregate gradient in the mixed design of shotcrete mixed designs and its relationship that defines the content from mortar? We see that many material suppliers promote pre-bagged shotcrete with an aggregate gradient of 0 to 4 mil. Is this right? Daniel, do you want to take this first?
Yeah, it's a very lengthy question, and I sort of struggled to sort of work out where this was going, but I think the way to look at this is that realistically, pre-bagged spray materials are actually called repair mortars anyway. So the hand-placed concrete repair products are called hand-placed repair mortars, and there's very little difference between that and what the person that asked this question, calling it packaged shotcrete, is. So small aggregates are used because generally you're using these products in repair situations. So they're going into application where you need to surround steel. You've broken out potentially sort of corroded steel, and you're reinstating in a lot of the cases. The mix can have fibers in as well, so it could differ a little from what people call mortars, but effectively there is no difference between a repair mortar and a spray repair material. I'm not sure if that sort of answers that exactly as the person who asked the question wanted, but Stuart, have you got any thoughts on it?
Yeah, I think that the design is really designed for the application. And if a project needs a bigger aggregate size than a 4 mil, then you know, there's a reason for that. And you're absolutely right. Most repair jobs that are used where a pre-bagged material is used, the aggregate is between 0 and 4, and that's because we want to ensure we're getting real good encapsulation around steel, and often we only break out to within 10-20 mil behind a steel bar. So if we have a larger aggregate, you may not get such a good repair. To jobs where the spacing of steel is bigger, then you could use a larger aggregate. But I think it's totally dependent really on the application.
Yeah, I think you covered that question well there. And whoever asked this question, if you do want follow-up advice from this, how we've answered it, then please get in contact with the Spray Concrete Society again. I'm sure we can follow up further more with that. So I think that then covers all of our follow-up questions we had. So we'll just say thanks again to everyone who attended on the day, and a particular thanks to anyone that asked the question. They've been really good, these ones today, and kept the guys thinking, and we enjoy the questions that come through live as well. So thanks again, everyone.